Hello everyone, welcome to the new video. So in this video we are going to write down a C++ program where we will show the how bisection method is implemented. If you want to know the theory, you can go through another video that I have already created. You can I'll give the link of the video in the description below. So here we are going to just implement the bisection method using C++. Let's get started. Okay, so we will be doing the program in dev C++. So first let us write down the header files. So we will be using hash include iostream. Since I'll be using mathematical functions, so I'm going to use header file cmath. Okay, now after that using namespace std, okay, followed by a semicolon. Now after that I'll be defining the function. Okay, you can use any function that is f of x you want, but here I will predefine it. Let us use x cube minus 4x minus 9 as the function for which we are going to find out the on which we are going to apply the bisection method. This is the f of x. So first we are going to define this function. So this function is going to return a double value. That's why return type I am using double. F is the name of the function, and argument I'll be passing the value of x, which is again of the data type double. So here it will be returning the value of x cube minus 4 into x minus 9. Okay, so this is the function that I have defined. Now let's go and before writing the main, let's go and see the algorithm. Okay, so this is the algorithm. So here you see we need to select two intervals a and b, and along with we should have a tolerance epsilon also, okay, based on which we will be doing the iteration. If you want to know about the details of the algorithm, you can see the video which I have already made, and a link of which is given in the description of this video. Okay, so for now we need three variables a, b, and the tolerance. Okay, so if we go back to the my program, so here I'll be needing three variables. So I will declare double a comma b and the tolerance. So let us write it as tol. Okay, now let's take the input for the numbers. Okay, so enter a and b. Okay, so C in A and B. Now what else we need? We need to know the tolerance also. So we will take the input for the tolerance also. So enter tolerance. Okay, that's it. So C in tol. Okay, so that's it. These are the variables and the inputs that we need. Now after this we are going to call the bisection algorithm. For that I am going to define one more function which I'll define here after this. Okay, I have kept to define it later because I want to do it step by step. So let the name of my function be bisection. So here I'll be passing the values of a, b, and tol. Okay, so I'm calling the function here. So here I will be defining this particular bisection function. So since there is the value, whatever is the result, it should be displayed inside the function itself. So this function is not going to return any value. So I have written void then bisection. Then inside here the data type of a is double, then data type of b is also double, and data type of tol is also double. Okay, now keep a mind here I have written a, b, tol. You can give any other names also as your wish, but it will represent the same thing. Since this is a call by value, so a, this value will be copied to this variable, this value will be copied to this variable, and this value will be copied to this variable. You can give some other names also, but I have kept the same names. So inside here I am going to define my bisection function based on the algorithm. So let's see the algorithm again. So after selecting the values of a and b, we will proceed only if we multiply fa and fb, the value is less than 0. It means both are of opposite signs. Otherwise, if it is greater than equal to 0, we are not going to proceed. So that's what we are going to write here. So here I will just write if f of a into f of b is greater than equal to 0, then what we are going to do, we are just going to see out, we are going to print invalid interval, right? Invalid interval means both the sign, both fa and fb are not of opposite signs, right? Either fa should be positive or fb should be negative, like that it should be there. Since it is not, so we are just going to write down invalid interval, and I'm just going to write down return. Okay, so this is one thing. Now we are going to proceed only if, now if this is false, suppose it is less than 0, then we are going to proceed with the algorithm. Now in order to proceed, we will be needing two more. We need to, if you see the algorithm, we need two more variables to declare. One is variable c, that is the midpoint, and another variable for the number of intervals, because if you see repeat steps 2 to 4 until this condition is satisfied, that is we need to perform some iteration, right? So we will be needing two more variables here. So let it be for c you can use double also, int also, it's up to you. So I will be using double, and for interval I can use int. Okay, int interval. Initial interval will be 0. We are going to start with 0. Okay, so now we are going to start the iteration, okay, inside here. So what is the condition for continuing the iteration? If you see the algorithm, you need to repeat the steps till b minus a is less than, greater than equal to, or b minus a becomes less than the tolerance value that we have given. So if we see our program, here we have given the, we have not mentioned here, so we will give some tolerance value. So till the b minus a interval becomes less than this tolerance, we are going to keep continuing the iterations, right? So while, I will just write down while while b minus a, okay, while b minus a is, let's give it inside a bracket. Okay, so inside the bracket I'll just write down while b minus a is greater than equal to 0. While b minus a is greater than equal to 0, we are going to keep repeating the iteration. So I'll just write down iteration. Initially it was 0, so now we will just write down iteration plus plus. Okay, so we are going to keep doing the iterations, or okay, fine. Now when the first iteration is going on, so it was, I have given this iteration just to show you how many iterations we'll be doing. Okay, so initially it was 0. Now when this condition is true, we have entered iteration number 1. So first thing, if you see the algorithm, we need to calculate the midpoint. Okay, so let's go and calculate the midpoint. So c equal to a plus b divided by 2. Okay, so we have got our midpoint. Now there is one more, if you see the PPT here, it is given, evaluate the, compute the function of f of c. Now we will have to write three possibilities. So first possibility, we will see if f of c is equal to 0, what we are going to do, we will be c is the root and the process stops, right? So here I'm just going to write if f of c, the moment I write down f of c, it is going to call this function. Here the value of c will be passed and this will be calculated, is equal to f of c is equal to 0. So what we are going to do here, we are just going to write down c out root is what is the value, c, and we are going to return from here, right? So we will just write down return. And if it is not the situation, then what we are going to write, I'm going to, okay, now this condition is checked. Now what are the other conditions to check? If f of a into f of c is less than 0, then we need to make b equal to c. Okay, so we are going to write if f of a into f of b is less than 0. So if it is true, then what you are going to make, that is a root lies between a and f of a into f of c, not b. Okay, if f of a into f of c is less than 0, it means the root lies between a and c. So we are going to make b equal to c. The value of b will be equal to c. If you see the algorithm, that is what it is written, b equal to c. Otherwise, what you are going to do, you are going to set a equal to c. So I will write down else set a equal to c. Okay, so this is what we have done. So here the loop, so this iteration will keep on rotating. Actually, we don't need this iteration also, okay, because since we are not going to display how many iterations we are going to use, so there is no point of declaring this variable here. So that's enough. So this is the algorithm. Now finally, after coming out of the sum, suppose the moment the value of b minus a becomes less than here not it's 0, it's not 0, it is tall. Okay, the moment the value b minus a becomes less than tall, here I am going to display the root. So the approx root is, so where I have where is the root present? In variable c. Okay, so this is my program. So let's save it first of all. Let's write down bis.cpp. So you can put it anywhere you want. I'll put it in the desktop, say. Now let me execute it, compile and run. So if I run it, enter the values of a and b. So let me give 2 and 3. Tolerance, let it be 0.01. So here you see the approx root is 2.71. So if you put the values 2 and 3 and tolerance as 0.01, you will get this value. If you're not getting this value, it means there is some problem with the coding part. Okay. So that's all for today's video. So I'm telling you again, if you want to know more about this particular algorithm, please go and see the video where for which the link I have given in the description, where you can understand this bisection method properly before coming to this program. Thank you, everyone.